Meet cryovolcanoes, the frozen wonders of the universe.
At first glance, Enceladus looks like just another lifeless moon. It's silent, frozen, and drifting through the cold shadows of Saturn. But beneath this icy shell, there's a mystery. There's something extraordinary happening deep below. In this world, volcanoes don't erupt lava, but ice. And with these icy outbursts comes an interesting possibility. Could there be alien oceans, plumes, or even life hiding beneath the ice? Let's explore together.
Enceladus, one of Saturn's smaller moons, reflects 90% of the sun's light.
Although Enceladus is small in size, just about 500 kilometers, 310 miles across, it's still one of Saturn's most intriguing moons. It's orbiting within Saturn's vast system of 146 moons, so it might seem unremarkable at first glance. However, this icy world has captured the imagination of scientists and even space enthusiasts. Since it's covered in pure water ice, Enceladus reflects nearly all sunlight that hits it, making it one of the brightest objects in the solar system. Its smooth, frozen surface is crisscrossed with fractures, ridges, and mysterious tiger stripes near its south pole. What sets Enceladus apart is what lies below, a vast subsurface ocean of liquid water, hidden beneath kilometers of ice. This ocean isn't just a scientific curiosity, but a potential habitat for life. Through cryovolcanism, Enceladus erupts jets of water vapor, ice, and organic molecules into space, telling us about the dynamic environment within. Enceladus, which was once considered just another cold rock in Saturn's orbit, is now a key player in the search for extraterrestrial life.
Icy worlds, and instead of erupting with molten rock, they erupt volatiles like water, methane, and ammonia.
Cryovolcanism is a type of volcanic activity that occurs not with molten rock, like on Earth, but with icy substances such as water, ammonia, and methane. These materials erupt as supercooled slush or vapor from beneath the surface to form what is known as cryovolcanoes. Instead of fiery lava flows, these volcanoes create icy plumes and spread frozen materials across their worlds. Cryovolcanism is found on some of the coldest and most distant bodies in our solar system, including icy moons like Enceladus and Europa, and dwarf planets such as Pluto and Ceres. Although these worlds may appear frozen and lifeless, according to cryovolcanism, they're geologically active below the surface. The driving force behind this phenomena is often tidal heating, a process where gravitational pulls from a parent planet like Saturn or Jupiter stretch and flex a moon's interior. This generates heat, which can melt ice into subsurface oceans beneath the frozen crust. Cryovolcanism is more than a geological curiosity. It's a window into the potential for life beyond Earth. These icy eruptions can deliver water, heat, and organic materials to a planet's surface, or even into space, making cryovolcanic worlds prime candidates in the search for extraterrestrial habitability.
The Cassini spacecraft finally arrived at Saturn, and what it saw shocked the world.
In 2005, NASA's Cassini spacecraft made a breathtaking discovery that changed how we see Enceladus and the search for life in the solar system. As Cassini flew past the moon, it captured images of towering jets of ice particles erupting from Enceladus's south pole. These geysers were shooting water vapor, ice, and organic materials hundreds of kilometers into space, escaping through long, fissured features known as the tiger stripes. Cassini observed that these plumes reached heights of up to 500 kilometers and were ejected at speeds over 1,200 kilometers per hour. Surprisingly, temperatures near the tiger stripes were warm. They were around -93 degrees Celsius, compared to the moon's average frigid surface temperature of about -200 degrees Celsius. This warmth suggested that the geysers were being heated from within, probably by tidal forces caused by Saturn's gravity. What was even more exciting was what Cassini found within the plumes. Instruments detected salts, indicating that the source was a liquid ocean in contact with Enceladus's rocky core. Organic molecules like carbon compounds and molecular hydrogen were also found, a potential chemical energy source for life. These geysers didn't just reveal the presence of a hidden ocean beneath the ice. They made Enceladus one of the most promising places to search for life beyond Earth.
Enceladus, one of Saturn's moons, hides an incredible secret.
These spectacular eruptions hint at something even bigger, a vast global liquid ocean hidden beneath Enceladus's icy shell. Although the surface of Enceladus is frozen and inhospitable, scientists now believe that there's a deep, salty ocean that spans the entire moon beneath its outer layer of ice, up to 20 to 30 kilometers thick. This hidden sea is kept in a liquid state not by sunlight, but by a powerful and invisible force, tidal heating. As Enceladus orbits Saturn, the gas giant's immense gravitational pull stretches and compresses the moon's interior. This constant flexing generates internal heat, the kind that's enough to prevent the ocean from freezing solid despite the frigid temperatures in the outer solar system. This process is similar to what powers volcanic activity on Jupiter's moon Io. But on Enceladus, it fuels icy geysers and probably even more. Deep beneath the ocean, where liquid water meets Enceladus's rocky core, there may be hydrothermal vents and cracks in the seafloor that release heat and minerals into the ocean. On Earth, such vents teem with life, supported not by sunlight, but by chemical energy. If similar conditions exist on Enceladus, then there's an exciting possibility that life could be thriving in the dark ocean depths of this tiny moon. The combination of liquid water, heat, and organic molecules makes Enceladus one of the most promising candidates for alien life in our solar system. Where there's water, heat, and chemistry, there could also be life, and Enceladus might have all three. On Earth, life has found a way to thrive in the most extreme environments, including the deep ocean floor. At hydrothermal vents, where mineral-rich, superheated water gushes from beneath the seafloor, entire ecosystems exist in complete darkness. These communities don't rely on sunlight, but on chemical reactions between water and rock to fuel life. If similar hydrothermal activity is occurring in the ocean beneath Enceladus's icy crust, that means this distant moon could have the ingredients necessary for life. Cassini's discoveries also fueled the possibility. As the spacecraft passed through Enceladus's plumes, it detected a mix of organic molecules, the basic building blocks of life, including carbon-containing compounds. As if that's not enough, it found molecular hydrogen, a potential source of energy for microbial life, just as it is for certain microbes around Earth's hydrothermal vents. These findings suggest that the ocean beneath Enceladus is not only present but active and potentially habitable. Looking ahead, scientists are eager to send new missions to Enceladus, equipped with advanced instruments capable of analyzing the plumes in more detail, or even landing on the surface. By studying the ice and vapor ejected into space, future missions could answer one of humanity's oldest questions: are we really alone in the universe? Cassini gave us a glimpse, but future missions could dive deeper into the mysteries of Enceladus. While Cassini revealed the icy geysers, subsurface ocean, and organic chemistry of Enceladus, it wasn't designed to confirm whether life exists there. The next generation of missions will have to take up that challenge and bring us closer to the answers we're looking for.
Jupiter's icy moons, Callisto, Europa, and Ganymede, hide a fascinating secret beneath their surface. All are thought to house deep subsurface oceans, some of them larger than the combined oceans here on Earth.
One upcoming mission is the European Space Agency's JUICE, Jupiter Icy Moons Explorer, launching to study Jupiter's icy moons, particularly Europa. While it won't visit Enceladus directly, JUICE will gather critical data on icy worlds, subsurface oceans, and habitability that could inform future exploration of Saturn's moons. NASA, on the other hand, has a bold concept in the works: the Enceladus Orbilander. This ambitious mission, which is still in the proposal stage, would first orbit Enceladus and conduct a detailed analysis of its plumes. Then it would descend to the surface and operate as a lander, conducting in-depth studies of the ice, chemistry, and possible biosignatures for many days. One of the most beautiful goals for any future mission is to capture plume material directly. Fresh samples from deep inside the moon, ejected into space by its cryovolcanoes. These samples could be analyzed for complex organic molecules, amino acids, or even microbial life. With each passing year, the excitement around Enceladus grows. What was once thought to be a frozen, inert moon is now seen as a potential cradle for alien life. And as technology advances, the dream of exploring this icy world up close and perhaps discovering life beyond Earth is closer to reality. Enceladus is small, frozen, and distant, but it might be one of the best places to search for life beyond Earth. Its icy surface hides a warm, dynamic ocean world, where cryovolcanoes erupt with strange, silent beauty. These alien geysers aren't just a spectacle. They're windows into the depths of a hidden ocean, possibly teeming with life. Imagine standing at the edge of one of those icy plumes, watching it soar into space, carrying secrets from a world beneath. Enceladus invites us to wonder, to explore, and to keep watching, because the most unexpected places may hold the greatest discoveries. It's indeed a world worth watching. Thanks for exploring Enceladus with us. If you like this icy adventure, kindly hit that like button and subscribe to our channel.